Hello class, today we're doing 6GO 6.1. Let's get started. Here we are doing addition with unlike denominators. We note that this denominator is 3, this denominator is 4, okay? We know the rule is that the denominators must be the same, okay, in order to add fractions. We ask ourselves two basic questions. Can we convert the lower number 3 to the higher number 4? In this case, no. There's no number times 3 that equals 4. However, we do know that 3 times 4 is 12, okay? And therefore, that's what we're going to use as our denominator, okay? Because we know that 12 they both have in common. So let's get started. If this denominator is 12 and this denominator is 12, then we did that because 3 times 4 is 12. So what we do to the denominator, we do to the numerator. 1 times 4 is 4. If 4 times 3 is 12, then 1 times the 3 gives us 3. So therefore, 1/3 is equivalent to 4/12, and 1/4 is equivalent to 3/12. Okay, and then we move forward from there. 4 plus 3, 7/12 is our answer. Okay, let's look at number 4. Number 4, we ask the question, can we convert 2 to 8? The answer is yes, because 2 times 4 would give us 8. So therefore, we're going to change this denominator by 4. So we have 3/8 plus 1 times 4 is 4, and 2 times 4 is 8. So now both the denominators are the same, and therefore we add 3 plus 4 is 7, and we keep the 8s, okay? Let's look at number 6. Number 6 is the same as number 2. We know that 12 is what they have in common. So we have 12 here, we have 12 here, and therefore 3 times 4 is 12, so 2 times 4 is 8. Here, 4 times 3 is 12, so 3 times 3 gives us a 9. So that 8 plus 9 is 17/12. Uh-oh, we have a situation where we have more numerators than denominators. So, therefore, we have a situation where we know that 12/12 equal 1 whole. Okay, so if we have 12/12 that equal 1 whole, when we remove the 12/12 from the 17/12, then we have how many 12s left? 5. So therefore we have 1 and 5/12 is our new number, simplified answer. Okay, all right, let's move on to number 8. On number 8, we have here and here. Can we can we convert 2 to 3? No. So let's multiply them. 6. So this is a 6, this is a 6. Okay? 3 times 2, 2 times 2. 2 times 2 is 4. 2 times 3, 1 times 3. 1 times 3 is 3. 3 plus 4 is 7/6. Once again, 6/6 is 1 whole. All right, we have more than 6/6. So when we remove 6/6 from the 7/6, we're left with 1/6. So we have 1 whole for the 6/6. And how many left over? 1/6. So 1 and 1/6 is our answer. Okay, let's look at number 10. Number 10, we have a 6, we have a 3. Can we change the 3 to a 6? The answer is yes, by 2. So we keep this one because it's already 6, but we change this one to 6. Okay, so that 1 times 2 is 2, and 3 times 2 is 6. So 5 plus 2 is 7/6. Oh, this number is larger than this number, so we know that 6/6 is 1 whole. So once we take that from this number, we're left with 1/6. Here, question, can we change the 4 to an 8? Yes, we can. So this is times 2, 6, 8, and we keep the 3 8s. And 6 plus 3 give us 9 8s. We have more than enough for one whole. 8, 8 give us one whole. When we remove the one whole from the 9/8, we're left with 1/8. So we have one whole, the 8/8, and then one left over, okay? Which is our new answer, okay? All right, let's take a look now at number 14. To make a ribbon and a bow for a hat, Stacy needs 5/8 yards of black ribbon and 2/3 yards of red ribbon. How much total ribbon does she need? So here's the black plus the red. Uh-oh, denominators are not the same. Can you change the 3 to a 6? Yes, you can. So let's keep the 6. Let's change the 3 to a 6 by multiplying it by 2. Now you have 4, 6, and now you have a total of 9, 6. We have more than enough for a whole. 6/6 makes one whole, so we got the one whole. Once you remove the 6, you're left with 3, 6, okay? And so that's that. But now we realize that this can be, this can be simplified, okay? Because 3 is in the family of 6, all right? So then we can simplify this. We have 1, so how many 3's are in 3 is 1, and how many 3's are in 6 is 2, 1 1/2, okay? That's our lesson. See you in the morning.